All right, I'm gonna give y'all another couple of minutes to work that out, and then we're gonna go over the review. Tomorrow for the test, it's there's a section where you balance and say what type of reactions they are, and then there's a section where you finish them like you had on your review, and you'll need to finish them in words, and then also the complete chemical equation. You won't have to write the reactants in words because I give you those. And then there's a couple of other things that kind of come from the notes that are on there that should be very easy. So on that other parts. So on your review that I gave you back, it should have a number plus something, however many, that's your points that you earned on the review. So that will be added to your test tomorrow. It's not multiple choice. It is not multiple choice. All right. So we're going to move on to the review. Let's pull it up here somewhere. No, it's yours to keep. So whatever works for you. All right, I'm not going to go over all of these because this is really back from last semester. The reason I put it on here is because writing the formulas has been a problem. And Ben and Jaheen, I did return y'all. So y'all can add to it because writing the formula has been the problem for a lot of people. And so that's why I gave you this. So if you want to look over that and check your formulas, and have 2 days of y'all working in class, very few questions. I had some people that have asked me questions, so that I like that, but very few questions. But yet when I saw the review, some people did hardly any of it. But never once asked a question. So I don't really know how to help those people out. So the reason I wrote the charges over here is so you could see why that would be part of the formula. Yes, ma'am. Mm-hmm. Because nitrate is the one that's lower, and so it's the one that has to have the subscript. And since it's a polyatomic ion that comes from the bottom, it has to be in parentheses before I can put the subscript. So some people like take, anytime they take a polyatomic ion off the bottom, they automatically put it in parentheses. So something like sodium hydroxide, the hydroxide doesn't actually need a subscript, but if you're started, wanting to get in that thing where I'm always going to put in parentheses, that is not wrong. And then that way, if you did calcium hydroxide and you knew it needed a 2, you would automatically do it. Because if you just did this, that would be wrong. Because when you do that, that 2 only applies to the hydrogen, not the hydrogen and the oxygen. Any other questions on those y'all can see? I'm going to move it up in just a minute. Move it up like that much. All right, give you all a chance to look at those. Remember, if it's a hydroxide, it's a base. So all of those metal hydroxides are all some type of base. And when we get to just acids and base, we'll talk about which one's a strong base compared to a weak base. Those are the ones, if you have hydroxide plus an acid, those are the ones that are a neutralization reaction. All right, and then here is all of our acids. One of the least favorite for everybody. So we have two kinds of acids. We have our, when we talk acids, we have our binary, and those are the ones that start with hydro. And so binary means two, so that's hydrogen just with one other anion. So those anions would come off of the top, not in the polyatomic. So then you would use your prefix hydro, sulf is a root for sulfide, and then those always end in ic. If it starts in hydro, it has to end in ic. And then we did the oxy acids that do not have hydro. And remember, all acids have to start with hydrogen. And so that's when we used our polyatomic ions. And if they ended in 8, it became ic as an acid. And then if it ended in ite, it became OUS. So you kind of had to work backwards. So for instance, sulfuric, since it didn't have to start with hydro, I had to realize it came from a polyatomic ion. So it's ic as an acid, it had to be 8. So this came from my sulfate ion. And remember when we did that, we took our 2 and we made it positive, and that became the subscript for my hydrogen. So that's where that 2 came from on that one. And you do the same thing for your binaries. Hydrosulfuric came from the sulfide ion. I took that 2 and I made it positive, and that's where the subscript for my hydrogen came from. And the reason that you do that is so they have to be neutral, just like our ionic compounds. So acids, nobody likes to name acids. It's always every year. So if you don't like acids, you're not alone. But I can guarantee you, you're going to see them tomorrow on the test. All right, on the next part, I'm going to move and I'm going to kind of work through them more. I'm going to pull up a different set of notes. Somewhere in here. All right. So number 1, it starts with just one reactant, so it has to be decomp. I'll kind of abbreviate it. And it's cobalt. So this Roman numeral tells me that's a 3, and hydroxide is a -1. So my correct formula would be COOH3. 3, that looks like it. And then I would have to go and I would have to look at my rules, which you'll have your notes tomorrow. And this comes from our decomposition. This is number 7 rule. And it says a metal hydroxide breaks down into a metal oxide plus H2O. So this is the one that I probably had the most questions on, because a lot of people just whenever they said a metal oxide, they just put CaO and then they couldn't get it balanced. But calcium is a +2. No, where am I at? We're not at calcium, are we? Cobalt. Cobalt is a +3. That tells me right here that it's a +3. It's not going to change. And oxide is a -2. So you couldn't just put them together like that. You couldn't just put COO. So that's why you had to give it the subscripts. And then once you did that, it wasn't so hard to balance. And the same thing that tomorrow, none of them are terribly hard to balance. The combustion, probably the worst. So if you get to one and it's really hard to balance, then go back and check and make sure that you've written it correctly. All right, so on this one, I needed 2 cobalt, so I'm going to put a 2 over here, which increased my hydrogen to 6. So I would come back and put a 3 over here. Next one is combustion. And you would also have to fill these out. I'm not going to have time to do every one of them, but you would also have to do this in words, just like all the practice has been done. You'll be given the reactants and you would have to write it like this, an equation, and then you'd have to also write cobalt 3 oxide. I'm going to run out of room, plus water. And if you didn't have that Roman numeral 3, it would be wrong because it's a transition metal. So next one, I have a combustion. I have a hydrocarbon plus oxygen gives me always CO2 plus H2O. On the quiz, whenever we took this quiz, some people missed all 3 of those because they didn't know what the products were. I can tell you have done no practice if you don't know that the products are CO2 and H2O. All kind of things came up. So you'd have to finish this with carbon dioxide plus water. And then you would have to proceed to balance it. If you just balanced it, first of all, with 4 carbon, then you ended up with the odd number of oxygen. So this is one of the ones you would have had to go back and kind of do that little trick of doubling up. 10, and that made this one 13. Next one, iron 3 fluoride. So that's a decomposition. And if you look at your rules, it's the most basic kind. It's number 1. It's just the ionic compound being broken back down into the metal and the non-metal. And you had to remember that it's a diatomic. And then you would have to do a little bit of balancing. And this, to finish that out, you would say iron plus fluorine. That's not chloride. This is neutral chlorine. If it was chloride, it would have to be part of a compound. That's an ionic form. Next one, once again, starting with just reactants. So actually the next 2 were decomp. So I'm going to go ahead and mark those. Lead 2 sulfate tells me that it's going to be PbSO4. So that's a metal sulfate. So if you went and looked at your rules, it's rule number 9, which tells you it's going to break down to a metal. It's giving me some dumb message. It's going to break down into PbO plus SO3. And we did those real simple when we did our notes, that those should always come out balanced. That's rule number 9. It breaks down to a lead oxide plus sulfur trioxide. All right, I'm going to have to get out here for a second. No, I don't have to tell you the other one. All right, so what are we up to? Number 5. All right, let's look at number 5, another decomposition. So aluminum chlorate, this is decomp again. Aluminum chlorate would be AlClO3, 3. So once again, if you're not checking your charges, this is a +3, this is a -1. If you're not checking your charges to begin with, and you're just putting two things together, then you're messed up from the beginning. Another decomp, this is number 5 from our rules. It says it's going to break down to a metal. So my metal in this case is aluminum chloride, and then oxygen, diatomic oxygen. So we would have to balance here. This one was actually kind of hard to balance. And the reason was 3 times 3, I had an odd number of oxygen, and I needed an even number. So as we've done before, if you have an odd number, you need it to be even. If you would have started with a 2 there. Now I have 3 times 2 is 9, times 2 would give me 18. So now I have an even number, and then I would need a 2 in front of here. If you have a question of where I've got a formula or something, let me know as we move through these. All righty. Next one. Don't think I can. All right. So number 6, another decomp. I'm on number 6. No, I'm wrong. Yep. There. So another decomp. Sorry, y'all. So I have potassium carbonate. Because potassium's a +1, carbonate's a -2. And a metal carbonate breaks down to a metal oxide plus CO2. And that one would, when you did that, that one came out, it was already balanced. Next one, hydrocarbon, and it doesn't matter that it has that oxygen added. We've done some of those on your practice. We talked about it in our notes and also on the journal. So this is still combustion. So my products of a hydrocarbon plus oxygen are always CO2 plus H2O, or you can put H2O and CO2. Doesn't matter which way. So this one was one of the ones that was a little trickier because I had to account for those oxygen that were here. So when we ended up balancing it, we had a 2 here, a 5, a 4, and a 6. I haven't done any single replacement yet, so that's why I haven't looked at my activity series, and I haven't done any double replacement, which I would need for my solubility rules. Although I think we eventually get to some. All right, next one, sulfuric acid, only one reactant, so there's going to be another decomp. H2SO4. If it's it now, it came from the sulfate, which had a -2, so that's why my hydrogen has a 2. And we said those are going to break down into water. And we're going to make them real simple. Take your water out. So that got rid of this hydrogen and one of this oxygen, and what's left over becomes your covalent compound or your nonmetal oxide. And if you looked at this, this was number 8 on our list of examples. And potassium carbonate would have been an example of number 4 when we looked at our rules. All right, next one. Move on up. Next one, we just have calcium and oxygen. So they're going to come together to form an ionic compound. So this is going to be synthesis. I'm going to end up with only one product. So I have calcium, just plain calcium off the periodic table, oxygen, and you got to remember it's a diatomic. Come together to form calcium oxide. And then I'd have to do a little bit of balancing. I need a 2 here because of my oxygen, which then would make me need a 2 for my calcium. This is oxygen because it's neutral. This is oxide because it's part of an ionic compound. All right, I think finally we got to a single replacement reaction. So I would have to get out my activity series. I have zinc plus H2S, that's hydrosulfuric acid. So what is the zinc trying to kick out? Hydrogen. So you would have to look on your activity series and see if zinc was higher than hydrogen, which I believe that it is. Zinc is higher. Yes, it is. So that's going to be a good reaction. Do not do any of these things. I do those to teach. That cannot be part of equation. I still have people doing that and putting subscripts up here. Those things, I've never put a subscript up here, but you got to leave your arrows off. That just do that whenever you're learning what kind of reaction. So it kicked out the hydrogen. I have diatomic hydrogen by itself and zinc sulfide. And it came out nice and balanced already. Next one, compound plus a compound. So this is a double replacement. Or if you notice, it's a hydroxide. So that's my base. That's supposed to be a B. And that's my acid. So you could also have named it a neutralization reaction. Either one I would have taken because that's just a specialized type. So this is the one where my products are going to have to show what state they're in. So I have iron hydroxide plus hydrochloric acid. So we said anytime we have a base plus an acid, that's a neutralization reaction, which means I produce water. And that's always in the liquid state. And then what I have left over, which is my Fe cation and my Cl, that becomes my salt. Because salt in chemistry doesn't just mean that it's sodium chloride. It's any ionic compound. This one I would have to look up to figure out what state it was in. And if you do that, it is AQ, aqueous. Remember, that is a good reaction. As long as you have water, that was one of our things that told you it was a good reaction. It doesn't matter if the second one could be AQ or it could be S. Either one would work. Fluoride. Yes, not myself. All right, a few more. Now where we at? I got my paper gold. All righty. Makes sense. So another single replacement reaction, and we have a non-metal. So my chlorine diatomic plus lithium bromide. The chlorine is trying to replace the bromide, which it can. So now I end up with bromine all by itself, diatomic, and now lithium and the chlorine come together to give me lithium chloride. And I got to do a little bit of balancing. All right, next one, potassium oxide and water. So this is a synthesis reaction. It's type number 4. I have a metal oxide, so potassium oxide plus water. You would look on your rules and it comes together. The metal oxide plus water comes together to give me a metal hydroxide. So potassium hydroxide. We have 2 of everything, so we needed 2 in front of here. And then we should be good. This OH doesn't have to have parentheses, or if you put in parentheses every polyatomic ion, that also would be okay. Next one, decomp, because I have only one reactant. So this is rule number 7. If you look at them, it says a metal hydroxide breaks down to a, well, it's just the reverse of what we did. A metal oxide plus water. So you had the synthesis where we made the metal hydroxide, the decomposition where we broke it down, and that one comes out balanced also. All right, moving on. If nobody has any questions, finish this page out, do those last. All right, 11. Element plus a compound. So this is single replacement, aluminum plus silver oxide. So aluminum's a metal, so it's trying to pick out my silver, which it can. I think silver's like way down on the bottom. So I end up with silver all by itself. And now aluminum oxide. And this one did take a little balancing. I think my oxygen, I needed a 3. 3 times 2 is 6, so that was easy to take care of there. Only affected the silver, and then come back and put a 2 with my aluminum. Magnesium element plus nitric acid. So that's single replacement. Magnesium trying to kick out the hydrogen, which it can. Magnesium's way at the top. So now hydrogen's all by itself, diatomic. If we were doing this in lab and really putting a piece of magnesium and some nitric acid, we would see bubbling because that would be a hydrogen gas. And now we have magnesium nitrate. And to balance that out, if you notice, you have 2 hydrogen and 2 of the nitrate group. So you just need a 2 in front of your acid. Next one, I have lithium sulfide plus silver nitrate. So compound plus compound. So it's going to be a double replacement. So my lithium, which is a group 1 metal, joins with my nitrate. So it's going to be AQ. All group 1 metals are AQ. And then I end up with silver sulfide. And if I look that up on my solubility rules, you should get S for solid. So that is a good reaction. So last thing you would have to do would be to balance it, which is a 2 here and I believe a 2 here, although this is on my key. All right, last few. Right here and another one. I have only one reactant, so another decomp. Potassium chlorate. And let's see, what rule was that? Metal chlorate. This is rule number 4. breaks down to a metal chloride plus oxygen. I'm sorry? I said a metal fluoride. Potassium is a metal. Oh, sorry, I was already past the other thing. Gotcha. Okay. Oh, and then I did it here. Oh, so it's not even a number 4, is it? I did it wrong on my key. Oh, I did it right on my key. Let's try that again. Sorry, y'all. It took me a while to catch up. So this is actually just number 1 of our rules because I have a ionic compound is going to break down to its original elements. It's metal and it's non-metal. And remember, y'all have a lot, there would be a lot of diatomics on that one, so don't accidentally miss that. So I would need to put a 2 here and a 2 here. All right, next one, copper iodide. Copper 2 iodide, that's why I had to put the 2 there, plus fluorine, which is diatomic. So fluorine is trying to replace iodine. So this is single replacement. And iodine is the very lowest, so we know it can be replaced. So now I have iodine all by itself and copper fluoride. And that one looks like it's nice and balanced. Next one, only one reactant, so decomp. Barium sulfate. And this is rule number 9. A metal sulfate breaks down to a metal oxide, barium's +2, oxides -2, so they didn't need subscripts, and then sulfur trioxide. So stays all nice and balanced. And last but not least, I have potassium sulfate plus magnesium fluoride. So compound plus compound, so this would be double replacement. So the magnesium and the potassium change places, and I have potassium fluoride, which is AQ, because potassiums are group 1 metal, so it's always going to be AQ, and magnesium sulfate, which you would have to find on your solubility rules. That one is also AQ. So this would be an NR, and then you don't have to worry about balancing or anything. You just put NR and move on. Huh? You can put it anyway, and if you realized it was going to be an NR before you wrote the products, because sometimes you can, especially if it's something like a nitrate or a potassium, you really don't even have to write the products. You could put just NR. This one I wouldn't have been able to realize because it's like not one of the obvious ones. Does anybody have any questions on any particular one that they need me to go over? Yes, sir.
So on like
Uh-huh.
when it's on what part of you write sulfur dioxide instead of sulfide.
Well, yes, because you only use salt that if it's an ionic compound, which is a metal plus a non-metal.
Okay.
But these are 2 non-metal, so you have to go back to the prefixes, which we don't use that much. We do a lot more work with ionic compounds. Yes, ma'am.
You know how, like, on the products, you put the barium with the
Uh-huh. On number 7.
unfortunately.
Okay, I was like, go back. Let me go back. All right, let's go back to 14 and I'll 14.
I was thinking
Okay.
how you get the product.
Okay, so at number 14. So this is, first of all, you got to know that only has one reactant that is going to be decomposition, right? So then what I would do, as soon as I knew it was decomposition, you're going to have your notes, open notes more, then I would get out my notes. And then I would say, what do I have here? I have a hydroxide, a metal hydroxide. So if you start looking down, then you could match it up with your metal hydroxide. And then once you did that, it tells you what it breaks down into. It breaks down into a metal oxide, and my metal in this case is barium. And you would have, this is where you'd have to double check your charges. And if you did that, you would see barium's a +2 and oxide's a -2. So that's why it didn't need any subscripts. And also water. So use these. I mean, I don't have all these memorized. I mean, because when I use them a couple of weeks out of each school year, my old brain needs room for other stuff that's more important. To me, the ones that you really have to use these on are like if it's a synthesis or a decomposition. To me, that's when it comes in most handy. Like a single replacement, you know, those are the double replacement, you know, they're switching places in the combustion. But to me, using your notes is most handy when you got a decomp or when you're making one thing. Mhm. Anybody else have any questions on any of them? Or any formulas? All right, well, y'all don't have much time. If y'all want to look over this or one of your other practices, and we're going to do this and move on to stoichiometry. I wish I could tell y'all it's going to get a lot easier, but this and stoichiometry for most people are the hardest 2 units. And then we go to something called gas laws, which is a lot of formulas, and they're not so bad. So if this has been a tough unit for you, you're not the only one. All right. No, those are yours. You know, you could practice them as part of your studying, but you will have your notes tomorrow. Ben and Jaheen, do you have any questions for me or on any of the review or anything? All righty, then we will see you tomorrow.